Okay, welcome. In this video, we're going to learn about the angle addition postulate, and then we're going to use that to prove statements. So, remember last time we talked about something called the segment addition postulate, which says that if I have a segment, say this is ABC, well, the whole segment, which is AC, right? If I took the measure of the whole segment, well, then it would have to be equal to the parts of the segment added up. That's what the segment addition postulate says, right? So in other words, it would say that the measure of AB plus the measure of BC has to be the same thing as the whole segment. So the parts have to add up to the whole. Now, we have the same thing for angles. So let me show you a visual. Now, the blue angle and the red angle would be the parts of the angle. The full angle is 103. Now, I can move this around, right? But if I move it around, it's going to make the red angle bigger and the blue angle smaller. But you'll notice the angles are still 103 degrees. And I can move this one down and make the red angle smaller, and the total angle doesn't change. It's still 103 degrees. That's what the angle postulate says. It's the angle addition postulate says. The parts of the angle, if I add up the red and the blue, will all get the full angle. That's all that it means. Okay, so let's see an example. Here we have a picture and some things. So I'm going to start off by just labeling the picture. First, it tells me that DBC is 2x plus 7. So that would be this angle here is 2x plus 7. It also tells me that ABD is 5x minus 7. ABD, well, that's this angle here. That's 5x minus 7. And then the full angle, ABC, is 70. Okay, so we're going to start off with the given. I didn't include everything in the given, so I should write that in. We also know not only that it's in the interior of ABC, but we also know that DBC equals 2x plus 7. ABD equals 5x minus 7. And ABC is 70. So those should all be in the given. We know all of those. So when we look at this, it says ABC. So let's label that angle. It says ABC. That's the whole angle. It's saying the whole angle is equal to ABD. That's this part. Plus this part. So what this is saying right here is that the two parts of the angle add up to the whole angle. So the reason for that is the angle addition postulate. The parts of the angle add up to the whole. And then after that, instead of letters, we have numbers here, right? And that means we must have replaced the letters with what the letters equal. So the word for replace, the math word, is the substitution. So we use the substitution property. And now it just becomes solving a linear equation. So notice I have some like terms. So 5 plus 2 is 7. And 7 minus 7 is 0. So those will cancel out. And I'll just get left with 7. Okay, I didn't move anything over. I just added things that were on the same side. So the rule is combine like terms. If they're on the same side, I can combine them. They're like terms. Now I need to get rid of the 7. It's 7 times x. So to get rid of it, I have to divide. When I divide 70 by 10, I get 70 by 7, I get 10. So that was the division property because I divided the 7 to get rid of it. And then lastly, we're trying to prove that x equals 10. Right now we have 10 equals x. So we know that 10 equals x is the same thing as x equals 10. The property that tells me I can flip, that's the symmetric property. And I'm done. Okay. Now in this one, I do not give you the picture, and I don't give you any statements and reasons. So whenever I don't give you the picture, it's best to draw them. So it's saying we have an angle. We're saying we have an angle BAD. So let me draw an angle here. BAD. Okay, this is BAD. And then it says C is in the interior, which means it's in here. An example of not in the interior would be like if it was over here. Okay, so C is in here. This is C. I'm just going to go ahead and connect right through C. And there we go. There's my angles. Now let's label. BAD, that's the full angle. So BAC, that's this angle here. And we're saying that's 8x minus 6. CAD, that's this angle here. That's 2x plus 11. And then the full angle BAD, well, that's 20. Okay, so let's just write the given. We know that BAC, so we're going to say the measure of BAC equals 8x minus 6. We have the measure of CAD is 2x plus 11. And we also know that the whole angle, which is BAD, the whole angle is 20. That's given. So angle proofs are often going to start with the angle addition postulate. So we need to start with the angle addition postulate. I'm going to write this over here so I have more space. So I'm just going to write this up here. Okay, so if I want to say the angle addition postulate, I need to say the parts of the angle. In other words, I need to say that this angle plus this angle equals the black angle, right? That's what the angle addition postulate says. The parts of the angle add up to the total. Okay, so that would be the red angle is angle BAC, so I'm going to say that the measure of BAC, the first part, plus the second part, which is the blue angle, would be CAD. That's the other part of the angle. And that has to equal the full angle, which is BAD. That's a bad angle. Okay? And that's the angle addition postulate, because I'm saying that the parts of the angle add up to the whole. Angle addition postulate. Okay, after that, we can just substitute the values in. We know BAC has a value of 8x minus 6. We know that CAD has a value of 2x plus 11. And we know that BAD is 20. Okay, so I replace the values. The word for replace, substitute. Okay, now before we move things over, we have some like terms. 8 and 2 are like terms, so when I combine those, I'm going to get 10. Negative 6 and 11 are like terms. When I combine those, I'm going to get 5. So that's what you get when you combine like terms, and the reason is combine like terms. Okay, now in order to solve this, I have to move the 5 over. So I need to subtract the 5, because in order to get something to the other side, you always do the opposite. The opposite of addition is subtraction. 20 minus 5 is 15. I use the subtraction property. After you subtract, I just need to get rid of the 10, so I'm going to divide. 15 divided by 10, well, it doesn't go evenly. If you put it in the calculator, it's going to tell you 1.5. That's the division property. And I'm done. Okay, last one. So this one, we have two pictures going on at the same time with some statements and some reasons. So the first thing is the given. We know this. They're telling us that. So I'm just going to rewrite that here. I know that angle WEC is equal or congruent to angle DUQ. And I know that angle CEB is congruent to angle QUL. Okay, so now let's look at this part. Since it involves W, C, and B, I know I'm going to be looking at this picture. So let's see what it says. I recommend labeling the picture as you read it. So WEC, that's this angle here. and CEB is this angle here. So what I'm saying is if I add up the parts of the angle, WEB is the full angle. So if I add up those two parts, I would get the full angle. The reason is the angle addition postulate. The parts of the angle equal the full. Okay, now they're saying that we're going to use the angle addition postulate again. We've already used it for this one, so now we're probably going to use it for that one. Okay, so how would I use the angle addition postulate to write a statement? So I would pause the video and try to do that on your own. Hopefully you did that. So this is a part of the angle, so I need to say that this part, that would be the measure of DUQ, plus the second part, which would be this part. Well, that's the measure of QUL. Well, that has to add up to the total, which would be DUL. That's the angle addition postulate. And then it's telling me here that I'm going to use the definition of congruent. So I'm going to look at my lines. There's only one thing that has congruent, and that is this. Right? Those are the only ones that have congruent. Remember, if something's congruent, it's the same size and the same shape. So after we say it's congruent, oftentimes we're going to say, okay, if it's congruent, then it's the same size. How I say the same size is just to include an M over it. So I'm going to say these are the same size and these are the same size. That's the definition of congruent. Okay, so now let's look at this line. This looks very similar. Maybe I'll underline it in red. This looks very similar to this. There's one difference, right? Everything is the same except for these two numbers, right? But if you notice, those two numbers, or those two angles, I should say, are the same. They're equal to each other. So it looks like what we did is we replaced the WEC with DUQ. The word for replace is substitution. We substituted the value of WEC, which was DUQ, so we used the substitution property. The next step is very similar. Doesn't this look a lot like this? Right? The only difference is instead of QUL, they replaced QUL with what QUL is equal to, which is CEB. So once again, we used the substitution property. We substituted the value of QUL into the equation. Okay, now let's zoom in on these two. What do we notice about these two things? Well, you may notice that the left-hand side is exactly the same. Isn't this and this the same? So if those two things are the same, then that means that we have two things equal to the same thing. And two things that are equal to the same thing are equal to each other. That's the transitive property. So since this is equal to the same thing, and this is equal to the same thing, then I know that those two things have to be equal as well. If they're equal to the same thing, they're equal to each other. All right? And notice that's very similar to what we have here, but what we have here is they say it's congruent. But if their measures are equal, then that means they're congruent. So I would say angle WEB. Since their measures are equal, by the definition of congruent, that means they're congruent. Okay, that's it for this video.